We're going to continue to introduce graphs in chapter 28. But first, I'm going to go to chapter 27 to look at the programming project 2. All the assignments in chapter 27, and they are due this Friday. So please take a note. This is due this Friday. I'm going to give you a hint on this chapter 27, programming project 2. I already gave you the hint for programming project 1 last time. So today I'm going to look at programming project 2. So this one here, you're going to implement the methods add all, remove all, return all, to array, and with another version. So those are the methods. We have it in my hash set, and was omitted. So now we're going to implement it. So let's look at this template. All right, so let's look at the template here. I'm going to open this template here. All right, so this is the programming project 2 template. This is exercise 27_11. So please read this test code. And here we have this main and calling the constructor, my new exercise 27_11. So this here we have the user to enter the strings for 3 arrays, name 1, name 2, name 3. So this is right here. All right, and then we created the my hash set from this array of strings. All right, so we continue now and see this here. And this is the copy from the book here. So this is my hash set implements collection. All right, so now we're going to see this. And here we have so all this copy from the book. And so now let's go scroll down to here, right here. All right, so we just add a new constructor. So this is the one we use. This is new constructor. This is edit. So this is actually give you some idea, see how you do this. And so you have any collection, and so you're going to create my hash set, and you just do this traversal, and for each loop, add each element in the collection into this my hash set. All right, so here is another new constructor. This is from an array of list. So now, and so what we do here is all right, I think this is something here. It's probably not really needed, but let's see. This is to invoke this NOAH constructor in my hash set. So I'm going to look at this is here, and this is NOAH constructor right here. All right. So this. And we set up everything here. And so this is to just initialize it, and here is everything here. Okay, it's actually it's needed. So yes, we need to set this up here. All right, so here. Okay. I'm going to add everything from this list into this. So I think I missed this. Should also put this right here, but probably it doesn't matter in this code, because let me check, make sure that if I ever use this. And here this is the constructor. See if in the test code, and we use this here. All right, in the test code, so look at the test code here. We create my hash set, and from this array of objects. So this is the string objects here. So here, so it looks like we did not use this here. So we did not use this. We use all the strings here. Okay. All right. So it has no effect, but it's actually it's an error here. We should actually add here this into this constructor here. Call this right here. All right. So this is the this has to be done. All right, so now you can write the code here for this contains all, okay? And to check if this, my hash set contains everything in this collection. So here's add all, and this is remove all, and this is retain all. And so this is the, so here is 2711. So let me just copy everything. And here. Okay. I think I'm going to do, I'm going to write this one here, retain all. Let's just copy this. I'm going to use this as a work area. So I'm going to have this right here, the work area. Okay. All right. So how do you implement retain all? So retain all is retains the elements in okay, we can copy this this description here. So here is the description right here. So it retains the elements in this it's no, this should be modified. So this is not correct. Okay. So it retains the elements in this hash set that are also in the collection, in the collection C, in the collection C. Returns true if this hash set changed as a result of this call. Okay, so retains all. Yeah. All right, I'm gonna write the code here. So we're gonna return Boolean. It's going to be a return and true or false, and depending on whether this is changed. So I'm going to put a Boolean here. Let's have a Boolean is changed. Okay. And this is going to return return changed. Okay, and all right, we're gonna assign a value here. Initially, let's assume it's false, it's not changed. So if we make a change, we're gonna assign true to this. Okay. Okay, that we can write it this way here. So I'm going to write this. We can use this. Write this for each loop. I think what we need is so if this contains, so we can remove it. Yeah, we can write it this way here is, yeah. All right, I'm gonna do this way here. For each element here in this collection, so we can just, can be just object here, any object here. It's this is a C here. In this is element in the C. Okay. If this dot contains and this element, all right. So if it doesn't contain it, so if it contain it, we're gonna keep it, retain it. So if it's not containing it, so then we can remove it. So we're gonna do this. This dot from this hash set, we're gonna remove this E. And we have this now changed is becoming true. See, this will continue for this for loop. Okay. All right, I just want to make sure this, when we have this remove E here, yes, there's something here is, it's about this data type. I just want to make sure, let's go back to this remove. So the remove method in this my hash set. So here we have, all right, so that should be okay because this is object, so that should be fine. Okay, so this remove is object, so that should be good. Okay, so that's going to be fine. This is any object E. So this can be anything. So this doesn't really matter. It's any type can fit into this object. Okay. All right. So that's how you're going to implement this retain all. Next, let's write another one is the to array. I'm going to write this one here. This is the to array here. Okay. Okay, so we're going to overwrite this method two array. So for this, we have this argument here. You're going to return, and this is the array to return this array. So eventually, you're going to return the same array. So you're going to get all these elements in the hash set and put it into this A and return it. So because this is the array, we're going to start from this index. We're going to have this as the index of the array starts from 0. And then we're going to keep copying from this. This is the so here is from this. So this is the hash set. And we're going to do this is the index, and after this, so index is incremented by 1, and you're going to assign this e to this, but you have to do a casting. So cast it into this type of this specified type T. All right, so then return it. All right, so this is the just some hints, and you can use this as example to implement and the other methods here. So please note, it is due this Friday. Next week, the Monday, we're going to have the exam. Any questions?
No, sir.
All right, thank you. I'm going to move on now to the next chapter. It's on graphs. All right, so we introduced graphs, and with this basic graph terminologies, and this how you represent graphs, vertices, and edges. And now we come to this modeling graphs. So we design our data structure. So we're going to have this data structure. We're going to create an object. This one object is going to representing the entire graph with all the vertices and edges. All right, so this is the design strategy. We're going to have this, the graph is the interface, and then we get into the unweighted graph, it's a subtype, and further, and we're going to add additional properties and to make it a weighted graph. So this is the overall diagram. And then we get down to this graph interface. So the graph interface, so here, we're going to have this method, get size, returns the number of vertices in the graph. And this get vertices is you get all the vertices into a list. And this is get one vertex using the index. So please note that we have all these vertices, and each vertex internally has a designated index. So that's the index. We can use this index to get the vertex. And we can get the index given the vertex. And we can get neighbors of all the vertex with the specified index into this list of the indices. So this is the integer for the index. And the get degree, and degree is the number of adjacent vertices. okay, and for a given vertex. So this is the index and get the degree for this. And this is print edges. You can print all the edges. You can clear is to remove all the vertices and edges from the graph. And so this is add a vertex. All right, add a new vertex. So if successful, return boolean, it's true. And this is add an edge. So you specify the index and this is this edge from U to V. All right. And this is to add an edge using the edge object. So please note that this is edge object. We have defined it in the previous section. So let's go to this now. Okay, so let's look at this. Here is this representing graphs. So when we look at the representing graphs and see they're right here, and this one is, this is the class. So here's the class. We define this. This right here, the edge. So here's the edge. And we define this edge right here. So this is the edge, right? Edge class, and this is the edge object. So the edge object is it's right here. And this is the this is the edge object, right here, edge object. All right, so this one is to remove a vertex, remove. And this is to remove an edge. So from U to V, the edge. So this is a direction. So from U to V. So U is the first and V is the second. All right, so this is the algorithm, and we're going to introduce, it's a very general, useful algorithm. It's depth first search, and this one is breadth first search. All right, all this is in the interface graph. And now let's look at the concrete class, unweighted graph. So now we're going to implement it. We're going to implement all these methods. So now we need to have internal data structure for storing vertices, and we use a list. And then for this edges, we use this neighbors. So the neighbors is a list of a list. So this is a list of the edges. So for each vertex, you're going to have a list for all its adjacent edges. So that's here, the neighbors is for this. So here now, the next are the constructors. We provide 5 different constructors, and you have different ways to construct a graph. So the first one is to construct an empty graph. So this is to construct a graph with specified vertices and the edges. So this is the edges. You use the simply use 2-dimensional array with all the edges. So all the pairs. So if you look at this here, this is the one we're going to use here. So here is this. When you use this, like this one here, this is edges. So this is from edge from 0 to 1. So that's corresponding to the graph. This is Seattle to this one is so it's, if look at, just make sure this is the one I'm saying, it's this right here. One is San Francisco, Seattle, San Francisco 1. So 0, 1. Okay. All right. So this is all here, you can have, this is the, if you have vertices and edges, this is the edges in a list of edge objects. Here's a list of vertices, so you can construct a graph. All right, so all this, you can practice this. Now, suppose this is already implemented. We can write a code to use it. So this is very helpful now when you study it. You don't have to jump into implementation. You can just write a code to use it, to get a feeling how this works. All right, so that's exactly what I'm going to do. Is I already have things here for you here. Now you can see here, I have this is the graph. That's the one. We have it at the map with all the cities, Seattle, San Francisco, Los Angeles, all this. And then we have this edges. So this is the edges here we have. So, all right. And then we create a graph. So we can write the code here is new unweighted graph. And now here we're going to have this is the using this constructor here, vertices and the edges. All right, so you create this, and now you're gonna say, I'm gonna get the number of vertices in graph one. So how do you write it? Using, call this method, graph one dot get size. So that's the method here we're gonna use. Okay, the vertex with index one is, all right, so let's get that vertex with index one. So this is graph one dot get the vertex. Get the vertex with the index is one. All right, so the index for Miami is, all right, so what is the index for Miami? So here is graph one dot get index for this city, Miami. All right, the edges, so you can now print all the edges. So here's another example and the graph, and using a different way to construct it. So this is using the edge objects in the edge list. All right, so I'm going to start from the scratch. So let me just wipe this everything out. All right, let's do this here. We're going to create a simple graph. This is an empty graph. So just write code like this and weighted graph. Okay. Okay. So please note that this is the, so what I want to do, let's use strings for the vertices. Okay, so I have this is look at this constructor here. So the V, so that's for the vertices, the type, data type for vertices. So this is the one. All right, so here I can print this, the number of vertices. So the number of vertices, okay, is g dot get size. All right, let's see if this is right. So if you run the code and you're gonna get this, it should be 0 now. There's nothing. So what happened? Just strange here. I'm gonna try this. Okay, it's something here. Maybe I didn't do it right. So here is string g new unweighted graph. Okay, system dot out dot print line. So here number of vertices is, so here g dot get size. Okay, so now just make sure I don't screw this up. Yes, just copy this now, run this. Okay, so this is the one. The number of vertices is 0 now. Okay, let's do this. I'm gonna share the screen now. This one here is this whiteboard. Oh, I just had this whiteboard. So okay, can you see what my whiteboard?
Yes.
Can you see it?
Yes.
Okay, good.
Yes.
All right, you see it. Okay, so I just draw a graph. So here's the graph I'm going to draw is this, and this. Okay, so I'm going to have these 3 cities here. This is Macon. So this is Atlanta, and this is Savannah. Okay, so let's have this graph with this 3 cities, and here is from Savannah, Macon, so this is a highway, and this is Macon to Atlanta, so this is a highway. Okay, I'm gonna create this graph. So I'm gonna go back to my okay, now I guess you don't see my my code right here, right? You don't do you see the code?
No, we just see the blue
Oh,
text.
You
and a
just
line.
did that. Okay, so then I have to reshare it. Let's see if I can do this. Go back to, yeah, I have to reshare it. So all right, can you see it now? See the code?
Yes, I see the Pearson website.
All right, thank you. So how do you create this graph now? I'm gonna add vertices. So this is G dot at Atlanta. Okay. So I'm gonna G dot at Macon. Okay. And G dot at Savannah. Okay. So internally, the one if it's the index is automatically assigned. So you have this Atlanta automatically become index 1 because 0 because there's nothing there. So the first one is 0. So the next one Macon is 1, and this is 2. All right, you add it this. So if you print this again, and the number of vertices, it should be 3. So if you run the code now, and you're gonna see this is the okay. All right, cannot find the symbol G. G dot. Oh, sorry. This says cannot find the symbol. Which symbol is? It's right here. The at. So it's not at. What is the method name? What's the name? You want to add vertex? What is that? If you go look here, it's at vertex right here. Add
Or
vertex.
add vertex. Yes.
Yeah. Okay. So we're gonna add vertex. Okay. So add vertex. Add vertex. Okay. So now just make sure I copy this. Okay. Then and let's do this wrong. See, now you have the number of vertices is 3. Okay. All right. You can find out the index for the each of the vertex by invoking the method g dot get index. Okay. So now I'm going to add age from Atlanta to Macon, from Macon to Atlanta. So how do you do this? So this is the method we're going to use, add age. So we can use this one. Okay. We're going to add age. Okay. But this is UV. This is a index. Okay. So you can do this way here now is G dot add age. Okay. So you can use this 0, 1, or maybe you're not sure, you can do this G dot get index Atlanta. Okay. And now, and here is G dot get index mechan. Okay, so that's one edge. All right, this is one edge. Okay, and then you can add from mechan to Atlanta. So this is another one, mechan to Atlanta. All right, so then from Meccan to Savannah, and from Savannah to Meccan. So here, Savannah to Meccan, and Meccan to Savannah. Okay. All right, I'm gonna run this code now. All right, let's add something here is we're gonna print. So here's the method we can use here. We're gonna print all this, all the edges. Okay, just print all the edges. So you just go with G dot print edges. Okay, print the edges. See, you see the printout here for Atlanta, the index is 0. So you have Atlanta, Meccan. All right, so Atlanta, you have Meccan. From Meccan, the index is 1, and you have Meccan to Atlanta and Meccan to Savannah. And from here, Savannah, you have Savannah to Meccan. So that's the graph here. And you can use others. You can say, I'm going to remove this vertex and remove edges, and we're going to do other things. All this is now, you can practice all these methods here and clear, and you can do others here, get the neighbors and get the degrees. So all this here. Yeah. All right, so we have now a sense of this, the graph. And how do we use this data structure? We're going to implement this data structure. So we're going to implement this data structure. It's right here. We're going to implement it. So we're going to write this this implementation for graph. It's straightforward translation from the UML diagram to the code here. So here, get size. Okay, and this is the get vertices. You just write this code, and so this one here, return the object for the specified vertex. So this one here is public. So return the object for the specified vertex index and get vertex, and this is int. It's the index. So use the index. So here's index. So return the index for the specified vertex. See, this is the public v. Return the index int, get index, and for this specified vertex. Okay. So all this here now. Okay. All right. So this is the concrete unweighted graph. So we have this unweighted graph, implements graph interface, and now here the internal data structure we have. We're going to use this. Look at this for the list of vertices. We're going to use this array list. So here, look at this. We're going to use the list right here. List. We're going to use array list. So the type is list here, but internally, so we can use list, but when we create it, we use array list. Okay, so here is the we call this vertices. Okay, and this is neighbors. So we're going to create all these neighbors and using, so here, look at the neighbors right here, and using this list list of ages. So I'm going to use all this, use array list. So here, we're going to use this new array list brackets array list of ages. Okay. So please note that this list is interface. Okay, so you have to use a concrete list to create it. All right. I want you to go after the class and to look into this implementation and see if you can understand how this implementation works. And so if you have questions, and bring your questions to the class next time. All right, so please really take your time to read it. So this is really the best way to study. All right, I guess I'm going to stop here now. Do you have any questions? So we'll continue next time. Any questions?
Hey, Professor, I had a question about the upcoming exam.
Yes.
I don't know if you already mentioned it or not, but what chapters is it going to be on?
Chapters 22 to 27.
Okay, and then is it going to be open book again?
Yes.
Open book.
So yeah, just please note that you have 50 minutes. You have to finish it. So there's no luxury of time to go to study the book. Okay. Just use the book as quick reference.
Thank you.
Yeah. All right.
Have a good one,
Any other
Professor.
questions? Yes.
No, have a good one.
All right. Thanks. Bye. Okay.